who are not able to make it. Good morning, everyone. All right, we'll continue with from where we started the last class. All right, I'm excited to see everyone this morning. All right, so we we reached a we have some more persons coming in. Give me 1 second. Let me just add them. Miss Edwards. All right. So we stopped at last class we stopped at the careers in physics, right? We stopped at the careers in physics. So before we start, can anyone all right, I don't think we'll be able to define physics, but can anyone state a branch in physics, just one? You can send it in the chat or you can turn on your mic. Anyone state a branch in physics that they remember from the last class?
Modern physics.
Modern physics. Thank you for that. Any more?
Thermodynamics.
Thermodynamics. That's good. I'll
Sir,
take one.
nuclear physics.
Nuclear physics. Are you looking in your book? Are you looking at the notes?
Answer.
I feel like you're looking
No,
at.
sir.
Okay. Um, please check that spelling, Mr. Redway. Thank you though for your response. Right. All right. And can anyone state any career in physics that they remember? Somebody highlighted a career in physics.
Sir,
Okay, go ahead.
Professor.
data scientist.
Right.
Then
Data scientist.
data scientist.
Right.
Mechanical engineer.
Mechanical engineer.
Professor.
Professor.
Earthquake unit engineer.
I feel like you're looking at it now.
No,
All right, we see the
Mechanical
astronomer
engineer.
coming. Yes, mechanical engineer. All right, thank you for that. Okay, now, all right, let me just add this person. Okay, so we reach far. We're at a far distance, right? In such a short time, we covered a lot. So let's just recap. So, all right. All right, so physics is a branch of natural science that focuses on studying matter, motion, energy, and force through space and time, right? So we study, just recapping, we study behavior of matter, we study motion. Remember, we spoke about the motion of a car, right? How an airplane flies, and so forth. And we studied these things in physics. All right, let's move on. And we highlighted some branches in physics already. Remember, you should just be able to identify them. You should be able to list them, right? You should be able to know them. You should know the branches in physics, right? That if I ask a question, right, you should be able to identify that yes, this is a branch in physics. I've seen this before, right? And we also spoke about the careers in physics, right? A data scientist, earthquake unit engineer, astronomer, physics teacher, professor, electrical engineer, and aerospace engineer, lab technician. I believe we stopped at mechanical engineer. We didn't. I didn't think to move on from mechanical engineer. I think the time ran out on us. We didn't finish. But the mechanical engineer, as we started to speak about a mechanical engineer as a person who studies the building of, they study they study the construction of many of our large buildings, right? They are the ones who play an integral role in studying large buildings, and they also play a role in building bridges, right? Large bridges that are able to hold many different cars, right? And buses at the same time. And an alternative energy engineer. Anybody know about alternative energy? Anybody ever hear that word before?
No, sir.
No. Anybody else? All right, so we're going to learn something new today, right? Has anyone ever seen a solar panel? Anybody know about
Yes,
solar
sir.
panel? Right,
Yes, sir.
Yes, sir.
right.
Yes.
And
Yes.
let me see somebody in the chat. Okay, and you know about wind farms, right?
Yes, sir.
We have a wind
Yes.
farm in Jamaica, and they consist of wind turbines. Look something like this, some big fans, right?
Yes, sir.
They take energy from the wind,
The wind.
right? They get energy from the wind and turn it into what?
Electricity.
Right. Thank you so much for that. They turn it into electricity. So these persons, alternative energy engineer, they study, they study, they they study how,
Electricity.
right? They study how to convert these things into electricity, how to convert sunlight into electricity. Because what happens is that we originally get electricity from gas, and when we burn gas, that leads to CO2, the release of CO2 or carbon dioxide. Remember what happens? We spoke about this yesterday. It goes up into the atmosphere, and what happens? It gets blocked, right? And it
Yes, sir.
causes climate change, right? We spoke about this yesterday. All right. So that's what the alternative energy. So we see, anyone see any based on what I explained, anyone see any career that they would like to go into? Anyone see any career that interests them?
No.
And what career, what do you want to do? What career you want to venture into?
Soldier.
You want to be a soldier?
Ew.
Yes, sir.
Santa says a big no, sir. Okay, not a problem. I don't feel anyway. That's not a problem, right?
Would I want to be one laptop engineer?
Astronomer. Okay, we see the astronomer coming. And Michaela says she wants to become a nurse. And that is a good thing, Michaela. Right? Alright, so we can move on then. Oh, we have more persons in the chat. A lawyer. Mr. Malik, I think you want to check the spelling, right? Check the spelling before you send the messages, right? Just double check your spelling.
Sir,
Basket
I
colour.
know, sir.
Go again?
I knew that I spelled it wrong, sir.
Yeah, man. No problem. No problem. No problem. Right? And a marriage counselor. All right. That has nothing to do with
Yes.
physics, but that's a good feel. Help persons to stay together. All right. So we can move on. And we have an electrical engineer in the building, right? Mr. Dawkins, right? He is the one that is going to come up with the newest phone, right? He's going to create the newest phone, newest technologies. And we have Jada who want to become a lab technician, right? And we spoke about a lab technician yesterday who sets up the lab, make sure everything is in place, make sure that the labs are done right fully, right? I think we can move on now if anybody else has any more careers. Once
Yes.
it pops up, yes, you have another career?
No, sir. I said we can move on.
Okay, okay, we can move on. Let's move on then. All right, so let me just check. All right, so the importance of physics. So physics is a fundamental element. All right, we have some more persons coming in, and let me just check the chat for a second. Yes, yes, this will be posted on YouTube. The link will be shared in the group like last class. I will try to do that every class so that every student gets access to the class. There was somebody in the group having trouble. Um, you could just send a message saying that this will be posted. All right, somebody can just do that for me quickly. Thank you. Or if you're not able to do it, I'll do it afterwards. All right, physics is one of the fundamental elements to other critical fields. You have critical fields such as chemistry. Anybody ever hear this word before?
Sir, what I said?
Yes, sir.
Right.
Yes,
So
sir.
physics is one of the fundamental elements to other critical fields such as chemistry. Right. Chemistry
Yes,
is another
sir.
subject,
Yes,
another
we
science
already.
subject. Right. I've heard it before. Engineering. Right. We heard about engineering before. Biology. Right. And even computer science. Computer science. Right. When we study computer, we study the programs and so forth, all of the things and all of the technical things and computers, right? Physics play a role in that. Why? Because um physics really is because of physics why the computer can be turned on. It's because of physics why you can actually use your phones, right? Everything in a phone has to do with physics. Electricity, right? This uses electricity. This uses a battery, right? Your phone uses a battery, and it is because of the battery why the phone is able to turn on. And batteries are developed using physics, electricity, right? And all of these stuff. So that's how important physics is, right? It is one of the backbones in the future, backbones of technological advancements in the future. So we spoke about the engineer and the fact that an engineer is basically someone or a physicist who puts theories into practice. Right? We spoke about this yesterday, right? That many of the things an engineer built this phone, right? And it because of theories such as in electricity and how batteries work and how atoms work and how different current work. These are things in physics. No? Current is physics come up with current, right? He was able to put this phone together, right? Because of these theories. Everyone understand?
Yes, sir.
All
Yes,
right.
Yes,
sir.
sir.
All right. So there are
Yes,
many concepts in.
sir.
All right. Thank you so much. So there are many concepts in chemistry that you will need physics to understand, right? And if you're going to do chemistry, you will come across these, such as power, right? Such as the gas law and chemical bonds, the bonding of different chemicals. When you put two chemicals together, what happens, right? Physics is a fundamental, right? And we spoke about the atom. We bring it up back again. Remember, we spoke about this. The atom
Yes, sir.
is the fundamental in chemistry. If you're going to do chemistry, you're going to come across this. You have to. You're going to do it in your third term, I think. In the third term, right? You're going to see this
Sir,
atom
what is it called?
chemistry.
No, that thing that
Atom.
This is called
draw.
an atom. This is an atom.
AOTUM.
C
Oh,
O
oh, oh.
M. Right. So so this was developed by a physicist. The structure. This structure here was developed by a physicist, right? And this plays a critical role in chemistry.
So,
Right.
sir, explain the point of that to me, please.
Okay. Thought you would never ask. All right. So we have this right here. This is a central part, right? This is where the positive. I don't want to go too deep, right? Because but let's just say this is a positive, the positive, and we call that. Let's just say this is the brain or the nucleus. The brain is called the nucleus is called the brain of the atom, right? I don't want to go too deep, but let's just say this is positive. In order for this structure to stay together, right? The
Stop do
other
that now. Whoever do it, mute on the mic, cause the and I me a try listen.
right,
Disgusting, man.
right. So this positive center right here, right, is attracted by the negative, these out here, these circles out here that cover the atom, right? These are called shells, right? And they are attracted to this positive center right here. This is the brain, and these are out here are negative, and they are attracted to this center. So if you want to learn more, I'm not going to go any further because this is not physics. This is not fully physics, right? This is not really what we want to cover today. We'll cover this in grade 11 and grade 12 and 13, right? But I'm just introducing to you that this right here is positive, right? And then you have the negative shells out here, right? Which are attracted to this positive center. So if you want, you can go on YouTube and you can look up the atom if you like, right? All right,
Yes,
so we
sir.
can move on, right?
Yes, sir.
All right, so the next section says that that many of the equipment in other science fields, other science areas such as medicine, they depend on physicists to come to study the interaction of of the equipment of the equipment, right? So we anybody ever hear about an X-ray machine?
Yes, sir.
What does this do?
Yes, sir.
Scan the body.
Right?
Scan the body, sir,
For what?
to see inside what is going on.
To
See
see inside
broken bones, sir.
broken bones. Perfect. Who you think come up with the X-ray machine? It's from physics. Remember what we spoke about optics,
Yes, sir. Have to do with
optics,
light.
light and so forth, right?
Yes, sir.
It
Yes,
stems
sir.
from light and rays, light rays, right? And it stems from different light rays, right? So X-ray machine was developed by a physicist, and this plays a very important role in medicine because the doctor can look on somebody's hand, right? Without the X-ray machine, they cannot determine where the bone is broken. They have to look on the machine to say, okay, there's a fracture here. It could be a fracture here, or there's a broken bone. You know, if you have a fracture, you won't need a cast, right? But if you have a broken bone, you're going to have to wrap the hand, right? So it is important that we know that that physicists develop these, right? And if the radiation from the X-ray machine was too strong, it could affect the body. It could affect the body, but it has to be at the right. It has to be at the right energy. It has to have the right amount of energy. So that's why physicists are so important in our society. All right. So another reason why physicists are so important is because um governments. Remember, we spoke about this climate change. We spoke about all of these already. But governments are looking to physics for information about alternative energy, right? Remember, we just spoke about that, converting wind to electricity with our windmill, right?
Yes, sir.
So we're looking because if we don't if we don't stop using oil as our source of energy, right? The effects of climate change would be larger, and you can go on the internet and look up climate change. Go on the internet and look up climate change, right? I will post a little assignment for you about climate change, okay? So you will
Yes.
get the opportunity to learn a little bit more about it, right? So the other thing is that we spoke about this also on Monday. We were introduced to this. Physicists determine the magnitude of an earthquake, right? Physicists can determine the magnitude of an earthquake after it happens, right? This is very important. Or they can possibly predict an earthquake. No. Last year, the physicists came out, the earthquake, Gabriel, I'm going to ask you to remove that. Thank you so much. So last year, the physicists predicted seismic activity. Seismic activity. All right, look at that word now. Seismic activity. When
Sorry,
they
is it seismic?
seismic, yes, the pronunciation is, what is the pronunciation again?
Seismic.
Seismic activity, right? You want to tell the class what that is? What
Sorry,
happens?
no, I don't heard this word before.
Right. So when there is seismic activity, it means that there could be an earthquake or a tsunami. Anyone knows about a tsunami?
Yes,
Right.
sir.
So last year, the physicists said that there was seismic activity in this region, and look what happened this year. There was about 4 or 5 earthquakes in Jamaica since year. 4 to 5 earthquakes at different points or surrounding Jamaica, right? Because they predicted seismic activity. So physicists are very important. So we have to be extra careful. That's why the government went out and say, they started to give out tips how to protect yourself in an earthquake, right? To go under the table, to hold, to go under the door thing. I don't remember that name, right? But that's not important. Right. The important thing is that we as physicists can determine the size. We can predict seismic activity. We don't know when an earthquake can happen, but we know that there is high seismic activity, and we can look at, for the person who has on the mic. I'm going to mute you, okay, until you have a question. All right, thank you. So we can also determine the category of a hurricane. So when a hurricane is coming into Jamaica, right? When a hurricane is coming into the Caribbean region, we want to know the category, right? We want to know the category. This is Jamaica, right? This is not Jamaica. Let's just say it's Jamaica, and the hurricane is heading here. We want to know the category. Is that category 1, 2, 3, or 4? We spoke about this yesterday. That a category 4 earthquake is has a lot more wind speed and can destroy a lot more buildings and so forth. Can destroy a lot more houses and infrastructure, right? So when we see a category 4 hurricane coming, we know we have to take extra precaution, right? Rather than a category 1, right? We can just ensure that we have our food stuff ready, and we can also determine if it's a tropical storm. Now, a hurricane it has a higher speed than a tropical storm. So in this time, or during the summer to October period, I encourage you to watch the news so that you get an update, right, of the different hurricanes and tropical storms that are in the region, and you will hear them talking about categories. You're placing them in different categories. All right, we can move on from here. All right, so we'll move on now to scientists in physics. We want to try and complete this today, right? So before Galileo methods, we have our first scientist as Galileo, right? You will see this name popping up again. So before Galileo, before Galileo methods were considered in the scientific community, concepts in science were only approached on the basis of thoughts and belief. What does this mean, right? Somebody could say that the earth is flat, and we know that this is not true. right? But somebody could say that the earth is flat and everybody would believe. The people on earth would believe, right? The people on earth would not have a problem with that. They just say, oh, the earth is flat, and we believe it. Or they could say that the sun is blue. We have a blue sun, but we know that that is not true. We know that that is not true. Or people could say that a tree is a person. Some very weird things, right? People could say that a tree is a person. People could say anything that they want, and then everybody else would believe it. Everyone else would believe it. What else? Um, People could say anything. People could say that water is a solid. People could come up with anything, and people would believe it until Galileo came as the only scientist in the world to prove these things. So Galileo would go ahead and prove anything that he came up with. So if people said that the earth was flat, he would make it his point of duty to prove that the earth is flat or not flat, right?
Yes,
So
sir.
Galileo was the only scientist at that time, right? Only scientist at that time that tested every theory, that he came up with. Every theory that is possible, he he tested it, right? Other scientists wanted to just come up with something that that the moon and the sun is the same thing. We have our moon, right? We have our moon and we have our sun, right? And people could just come up and say that, oh, the sun is the same thing as the moon. Galileo would come and say, no, that's not the case. It's just an example, right? Galileo would come and say, no, let me test that for myself, right? And then he would use his experiments to come up with the fact that the earth, the moon and the sun is not the same. Or people could just say that there's just one planet in space. Scientists could just come up and say that, oh, there's also one planet in space, and the sun and the moon is the same. But then Galileo would come and say, no, let me test that for myself, right? So Galileo was a very important man in the scientific community, right? And he tested everything. He made sure that had everything that he came up with had evidence. Just that when you go to court and somebody say you steal the bubble gum, you were the one that stole the bubble gum, right? If Galileo was not here, people would say that people would believe. But no, Galileo made sure that you had evidence to prove that you did not steal or you are innocent. That's just an example, right? Everyone understand Galileo?
Yes, sir.
Yes, sir.
Yes,
Yes,
Okay.
sir.
sir.
All right, that's wonderful. All right, so the next person is Sir Isaac Newton, right?
Heard
So
that name before, sir.
go again.
I've heard that name
You have
before.
heard that name before, and who is it speaking?
He's a scientist, I think.
Yeah, he's a
Sir,
scientist.
sir, we know about, taught us about gravity.
Right, right. Thank you so much, Mr. Dawkins. Thank you so much. Right, he was a person who came up who taught us about gravity. Now, before Sir Isaac Newton, people people used to believe that the Earth, say we had a ball up here, and this is the planet, the Earth. People used to believe that the Earth go up to meet the ball. It's funny, right? Or
Yes, sir.
we had people used to believe that the earth go up to meet the ball, but then Sir Isaac Newton came on the scene and he tested that when the ball is here, it faces a force of gravity which pulls the ball to the ground and the ball begins to fall. Right? We'll pause here and stop the lesson here, and then we'll come back for this the second part. Remember, the Zoom um the Zoom only allows 40 minutes for now. Right? So we'll pause here and then come back, okay?
Yes, sir.
Just click the same link and then
Yes,
it'll bring
sir.
you straight back here again. Alright?
Yes, sir.
Okay.
Yes, sir.